Okay, so I've had a request on how to do a KenKen. So, kind of like a Sudoku, where usually we have 1 through 9 in the rows, 1 through 9 in the columns, 1 through 9 in the boxes. This is a small KenKen, and we're going to be doing 1 through 5, and that's going to be 1 through 5 in each row, 1 through 5 in each column, but it's not 1 through 5 in each of the boxes. Those boxes are going to follow whatever operation they have in the top corner. It's going to do plus, minus, times, and divide. And the number given there is going to be what those two numbers would add up to or subtract to or divide to depending on the operation. So like for example, this right here where we have a 5 and then a divide, that means the two numbers in these boxes should divide to 5. And the two numbers in these boxes should multiply to 4. So I'm going to start off with what I know for sure. There's a 4 in this corner. That is kind of telling me that this is going to be a 4. There's nothing else there. I got another one right here. This is a 4. I got another one right here. This is a 3. So like I said, this 5 divide means these two boxes need to divide to 5. 5 being a prime number, the only way to do that is 5 divided by 1. Now I don't know yet, is it a 1 in the first box and a 5 in the second, or is it the reverse, is the 5 first and then the 1 first? So we're going to have to use some kind of logic skills to go around and see what we can figure out. Like for example, this 4 times. Now there are two ways to get to 4. We could do 2 times 2, or we could do 4 times 1. Now that 2 times 2, that's not going to fly. And it's because I can't have two 2's in the same column. So I can't go 2, 2, because it's got to be 1, 2, 3, 4, 5 in this column. So it's for sure got to be the 4, 1. With this 6 times, I can't really do 6 times 1 because I'm only using the numbers 1 through 5. So it's going to have to be 2 times 3. So as you kind of get the idea, we're going to work our way around trying to fill in 1 through 5 in each row, 1 through 5 in each column, and then matching up to the operations as we go. So I'm going to go ahead and finish this first one. Using the fact that this has to be 2 times 3, I cannot put a 3 here because there'd be 2 3's in this bottom row, which means there has to be a 3 here, which means there has to be a 2 here. Okay? I think I'm going to jump up here. I noticed this 15 times. I know that that has to be 3 times 5. Now I'm not really sure yet which of those is a 3 and which of those is a 5, but I do know that means there's going to be a 5 in this column. And the reason that's important is because way down here, there cannot be a 5 here because there has to be a 5 in that column up there. So if that's not a 5, my bad. If that's not a 5, that means that has to be a 1. Which means that has to be a 5, which means that has to be a 4. And I know that because the bottom row has to be 1, 2, 3, 4, 5. So if you keep going, I already figured out that if this is a 4, that this has to be a 1. And maybe over here, right? 5 divide has to be 5 divided by 1. And because I already have a 1 in this row, I can't have a 1 here, so this has to be a 5, which means this has to be a 1. Okay, let's keep going. Where can I go next? Maybe we should look at this 48 times. So 48 is kind of a big number, but I'm going to say, well, I know that 6 times 8 is 48. And maybe I'll break those down into 2 times 3, and then 4 times 2. Okay, well, like I said, I know that there's a 3 here, so that means there cannot be a 3 here. And because I have a 3 over here, there cannot be a 3 here. That means that 3 will have to go in this top corner. Now I said 2's can't go next to each other, so I can't go 2, 2. I can't go 2, 2. The 2's will have to go diagonally. And now I have 4 out of 5 filled in this row, 4 out of 5 filled in this row, so I can easily see what's missing. 1, 2, 3, 4, 5. And that works with my 48 times too because I had a 3, 2 2's, and a 4. And now I got 1, 2, 3, 4. That means I gotta have a 5 here. Okay, let's keep going. I'm going to break up 30 times, and hopefully there's enough space right here. 30, I can break it up into, how about 2 and 15? And then I can break that up into 3 and 5. Now that is the prime factorization of 30, but this is telling me I actually need to have 4 numbers. And even though I only got a 2, a 3, and a 5, that fourth number is just going to be a times 1, because you can always times by 1 and it won't change your answer. Okay, so this column for sure is where my 1's going to go, because now I got 1, 2, 3, 4, 5 in that column. And I need to put a 2 and a 3. I don't think I have enough information to do that yet, so I'm going to keep those on pause, knowing that there's going to be a 2 and a 3 in these 2 boxes. Let's go to my 40. If I was going to break up 40, I'd probably go 4 and 10. And we already talked about 4 having 2 possibilities. It could be 2 and 2, or it could be 4 and 1. And then 10 would have to be 2 and 5. Now, I think this isn't going to work out for me because I'd have too many 2's. I can't have 3 2's because then there'd be too many next to each other. So it looks like 40 is going to be 4 times 1 times 2 times 5. So I'm looking at 4 can't go here because there's already 4 in this column. 4 can't go here because there's already 4 in this row, which means 4 has to be here. I'm looking at the 1. 1 can't go here because there's a 1 in this column. 1 can't go here because there's a 1 in this row, so no 1 here, no 1 here means 1 is up here. Now I got 2 and 5. So 2 can't go here because of the 2 in this column, which means the 2 would go up here, and that leaves 1 spot for my 5. And now we really can figure everything else out, because if the 5 is here, that means the 5 can't go here, so I got a 5 up here and a 3. If 3 is here, that means 3 can't go here, so I got a 2 here, and then I got a 3 here. And that makes sense. I had the 2 and the 3 I knew I needed. I got the 2 and the 5 I knew I needed. I got the 5 and the 3. And that looks like a completed KenKen. So same idea for these other smaller ones, 1 through 5s. And if you're going to keep going to the large one, it's going 1 through 9. So 1 through 9 in every row, 1 through 9 in every column. And again, following those algebra rules, like if we're trying to subtract to 6, it's going to have to be 9 minus 3, or it's going to have to be 8 minus 2, or it's going to have to be 7 minus 1. That'd be the only possibilities, right? But we don't know which one's the 7, which one's the 1. We'd have to go and work around the rest of this to try to figure that out. Good luck with that, and let me know if you need help.